Hello and welcome everyone to today's webinar, Boosting Your Applications with Oracle NoSQL, Global Active Tables, Simplicity Hides Complexity. Thank you for joining us. My name is Tara Van Cleve and I am a Marketing Event Manager for the Developer Initiative here at Oracle. And today we're excited to show you a live demonstration of the Global Active Tables feature in action. We'll also be recording the session and we'll send the replay to the same email that you registered with for today's event. If you have any questions during the webinar, please drop them in the Zoom chat and Q&A areas and we'll be ready to help answer them there. We've also set up a channel in our developer public Slack called Oracle NoSQL that you can access at the QR code or at bit.ly/odevrel_Slack. This channel will remain open after the event to contact us directly with any questions and to share resources with you. So today's webinar will be presented by Michael Bray, Director for Oracle NoSQL, and Dario Vega, Principal Member of Technical Staff for Oracle NoSQL. So without further ado, I will first hand it off to Michael.
All righty, thank you. All right, welcome everyone. So today's agenda, we're going to talk a little bit about different database types, a little bit about Oracle NoSQL Database, and then we're going to hit the primary topic, which is a recent feature that we announced in the cloud called Global Active Tables. Interspersed through that discussion will be a couple of demos, which Dario will be presenting. So in today's market, what we see is a lot of different databases. So we have what we call key value databases. And then on the slide, we have a list of the sort of examples of those. And the Oracle NoSQL database can serve in a key value type of manner. Key value is simply a structure in a database where really you have two fields. You have a key and you have a value. Technically, to the database, the value is totally transparent, and the application basically controls how the value is read and understood. We also have what they call wide column databases, which is fairly new. It's basically a specialized form of a sort of generic NoSQL database. Again, we have examples of it, some explanations there. Oracle NoSQL can perform as a wide column database if that's how you would like to use it in that type of context. We have document stores, very common terminology that's out there in the industry is a document store. Again, the Oracle NoSQL database can perform as a document store. We have a relational databases. Again, they've been around for some 20, 30 years now. Most of the major companies out there have them. Basically, what you get with a relational data store is you get a fixed columns, and then each of those columns has a defined data type. If you want to do it that way with the Oracle NoSQL database, you can do that as well. Finally, we have graph databases, very specialized, and you can certainly use the Oracle NoSQL database as a graph database if you so choose. So there's really a lot of different sort of styles and flavors and techniques and ways that you can use the Oracle NoSQL database. What we have here is basically some common types of applications where we see a NoSQL database being used. We see it for content management, the handling of user profiles and session management, very common in IoT data. And usually when you get IoT data, what also comes along with that is a time series component. Catalog management, managing a catalog of products, similar to you go to your grocery store and there's a catalog of products if you can do ordering. Walmart uses catalog management. All kinds of stores use some form of catalog management, social media, and gaming. Gaming gets used a lot in the sense of, keeping the status of the game, keeping track of the players, keeping track of essentially metadata for the game. Caching, a lot of the effects that you see with caching, again, is really a metadata store, and then multi-tenant applications. With Oracle NoSQL, we really like to highlight three particular things. We want to basically say, hey, with using the Oracle NoSQL database, you can innovate fast. You can drive your business outcomes. You have agility. You have flexibility. You have elasticity. We view ourselves as basically one of the most flexible NoSQL databases out there on the market today. Since the beginning of development for Oracle NoSQL, we have put an emphasis on what we call delighting the customer. So we've put a focus on being very developer friendly, being very developer open. We do a lot of our development on GitHub. We will take changes from the community. And we feel like that's a very efficient way to work. We are an open source database. If you want to come grab it, if you want to use it at no cost as an open source database, you can do that. So, we also offer a Oracle license. So if you want to use it that manner, you can do that as well. And one of the other things that we've really focused on is basically the speed, right? So every time that we make decisions, we have performance and speed in mind. And then we view it basically as a simple experience, right? Build smart, build fast. We are totally serverless. We have a fully managed cloud version. You also have on-prem. We have a wide variety of development languages that you can use. You can also use SDKs, CLIs, APIs, and we are encrypted at rest and in transit. Why do businesses choose Oracle NoSQL Database? In particular, the cloud service, it's fully managed. As I showed in the very intro slide, right, we have multiple data models that we can use. Now, in this case, I'm going to use slightly different terminology than what I used in the original slide. But basically, we have document. Columnar is basically nothing more than a relational database sort of style. And then there is a key value. And we support all of those with a single application interface. And that application interface can basically be used in any of those different models. We have easy to use APIs that are integrated. And one of the other things that we do, which is different than a lot of the NoSQL databases out there, is we use the SQL language as our underpinning. We find that a lot of the students coming out of the colleges today, they all have experience with SQL. They know how to write it. They know how to understand it. And so it's very easy to adopt the things that you have learned at the university and bring that over to using the Oracle NoSQL database. We're fully elastic. You can scale up, you can scale down. We have a enterprise-grade security. We are always available. In terms of the various services that are offered by Oracle, we are highly available, and we are the most available of all the different services. We offer high performance, and in that context, we offer that with predictability. So one of the things that we guarantee is that the reads are going to be in the 2 to 4 millisecond range, and writes are going to be in the 6 to 8 millisecond range. And our goal continues to be basically below 10 milliseconds. So basically single digit millisecond latencies. We have a low operating costs. And for some of our customers, they really like this final point, which is the ability to operate in multiple clouds, the ability to to operate within a hybrid. So you can run part of your application on premise, and then you can run part of it in the cloud. Our service in the cloud is fully managed. Oracle takes care of managing the servers, the network, the security. We handle all the software installation, the updates, the security monitoring. We are constantly monitoring the health of each of our regions. And we have all kinds of internal alerts set up that if the slightest little thing goes wrong, our DevOps team is alerted, and we're dealing with that immediately. You can configure, we do the underlying configuration for global active tables for basically built-in replication. And all you do as the user is what you end up doing is you end up focusing on your application development, your data model design, and who's going to access and run your application. So this is our 14th year with a NoSQL database here at Oracle. We have a large development team. The team is distributed across several different continents, and so we're really doing development 7/24. And then we moved to the cloud in 2018, and then at the end of 2023, in the October timeframe, we announced what we call our global active tables feature in the cloud. So what does global active tables do? This is basically a way to replicate a table across multiple regions in a given cloud. Now, within our cloud, you can have two different kinds of read and write capabilities. You have what we call provisioned or on demand. You could set up your global active table with either one of those. Each of the tables will be a replica or will be a copy of one another. Any types of write activities that occurs in region 1, those writes will be asynchronously replicated over to region 2. If you do writes in region 2, those writes will be replicated to region 1. Now, you're not just limited to 2 regions. If you have an application where you need 2 copies or 3 copies or 4 copies, you could do that. So that is not limited just to 2 different copies. As I mentioned, we will handle, as the service owners, we will handle the synchronization of the data between the 2 regions. We will handle that asynchronously. The data is automatically propagated. We have built-in conflict resolution. So if it happens that 2 different regions try to update the same piece of data at exactly the same point in time, we will deal with that particular conflict. The way that you can create your active tables is through a simple set of APIs and SDKs and CLIs. For those customers that already have an application, that application can start using a global active table immediately with no changes to the application. So in that case, what you would do is you could create the global active table via the console, and then your application could currently use it. The fact that a table from the point of view of the application is a global active table or what we call a singleton table is basically invisible to the application. And this can be used across any of the different data models that we offer, whether it be key value, document, or fixed schema. So what does this give you? This gives you a high performance across all the regions. The delay that you would pick up is basically the asynchronous delay, which is basically moving the data from one region to another region. But the beauty here is that you can have your application running in multiple regions, and they can be accessing the data locally. This next slide covers some of the business benefits of global active tables. I'm not going to go through all of those. I'll leave this screen up for a moment or two. But essentially, one of the things that it will do is it will reduce cost. We can minimize risk because now we have data in multiple locations. So you can get increased higher availability. You can get disaster recovery. You can transform your business because now your business, all of your accesses to your data will be local. And then finally, you can accelerate innovation. All right. What we're going to do now is I'm going to pass it over to Dario, and then I'll let Dario do a high-level demo of the global active table feature in the cloud.
Okay. So here I am in the cloud. So we have multiple possibilities. For example, we have Oracle Database, and we have all the flavors of Oracle Database. We have Autonomous Database. We have Exadata. But we have what we call other database. So we have the possibility to have Postgres, the possibility to have MySQL, OpenSearch, Redis. And of course, we have the possibility to have Oracle NoSQL Database. As you can see here, when I click here in Oracle NoSQL Database, here, for example, I am in Paris. So as you can see here, you don't need to create any database or any cluster. Behind the scenes, we create the cluster for you. It means, for example, if you need to choose, if you have 3, 4, 5, 6, 7, 8, 9 nodes, you don't care about because we are doing this for you. The only thing that you need to do is to create a table. Okay, for example, I can create a table by providing my primary key. For example, I can say that is an ID. And I can say that I will put all, I will call this key. I will put all the data in a field that I will call value, and it is JSON type. And then what I need to say is what is my capacity, what I am expecting as reads and writes in this table. Okay, I will cancel here because I already prepared a table for you, and it is here in front. Okay. So as you can see here, we will use this table. And in this table, as you can see, I have read units 20, write units 20. I have a capacity of 20 gigabytes. I have what we call time to live. It means that when I am inserting a data, it will automatically expire after 7 days. Okay, so just let me query a little bit here. Oh, sorry, that's not a good one, query. So let me show you. Currently, I insert only 2 data. And as you can see here, I have a JSON document. So inside this document, I have the information for my customer. I have some shows, for example, that is an application that we already present during another meeting. And here you have the information that you have behind the scene. We have a GraphQL deployment, a GraphQL application. And as you can see here, for this row, I am saying that it is not expiring. And for this row, it is saying that it is expiring, okay? Another thing that I have here is I have some indexes based on the JSON document. And now I want to show you how to create a global active table. So as you can see here, the only thing that you need to say is to choose when you want to create a replica. So in this case, for example, I will go in Santiago, Chile, and I can say what is my capacity for Santiago. In this case, I will say that I have a lot of activity in Santiago, so I am expecting to have more capacity in Santiago, okay? The interesting thing here is, as you can see, we have 20 gigabytes of data here in Frankfurt. I will have the same number of gigabytes in Santiago when I am doing this replication. So just let me go here. We will create our replication. So it is waiting. And it is starting to create the new replica in Santiago. So as you can see here, I am in Frankfurt, and now here I am in Santiago. So the first thing is, as you can see here, I have the same table with the same name. And here, when I am looking for this, currently we are still doing the initialization. So we are copying the data from Frankfurt to Santiago. It is finished. When I will execute exactly the same query, I will have exactly the same data that I have in Santiago in Frankfurt. Okay, as you can see here, I have the same time to live. I don't have the same capacity, but I have the same disk. And if I go to the indexes, I have also the same indexes. It means, for example, if I decide to change the time to live, it will automatically change it in both sides of the table. So it will change here in Santiago and automatically here in Frankfurt. In the next presentation, in the next demo, I will tell you why this kind of thing are important. But just before to finish this demo, I want to show. So I have some data, and I will insert more data to this table. In this case, I will use SQL. That is one of the questions in the chat, and I will tell you why it is interesting to use SQL in this case. So just let me do some small modifications here. I don't know, let's check the spelling. Okay, so for example, as you can see here, I am inserting a new line in this table, which this ID 3. And as you can see here, I have a JSON document. It is not a string representing a JSON document. It is a JSON document, okay? And I will answer, and I will say that I don't want to use my default ETL, but I want to change the default ETL. And in one command, I will do some modification, and instead of returning the data that I am inserting in the database, I want to do a kind of SQL. Okay, so as you can see here, that is an expression. So here I am creating a JSON document. So it is a mix between jQuery and SQL. And this is why we are saying, even if we are in a NoSQL database, we are using these different APIs with the same command. Okay, so I will insert here this data. Oops, I forgot something. Okay, here. So I insert my data, and if you look here, I have my summary, and I am saying that my data will expire in 1 hour. Now let me go here to Frankfurt. I will execute the same query, and as you can see here, I have 3 rows. Okay, Mike, it is finishing my first demo.
All right, so thanks for that demonstration, Dario. Appreciate that. So let's go over sort of a little bit more of some of the lower level details of what makes global active tables work. So what Dario showed was basically 2 regions. And here on this slide, we're showing 3 regions. We showed 2 regions in the demo just for a matter of simplicity. But really what you have with global active tables is you have multi-active, multi-directional, cross-region data replication. And the beauty with that is it is built in to the product. You don't have to add any other additional products. You're not trying to coordinate 2 different types of authorizations or anything like that. This comes built in with the Oracle NoSQL Database Cloud service. And while we're here, I should also mention that we have had the equivalent of global active tables in the on-premise product for several years now. Because the way that we set it up for the cloud is different than the way that we set it up for on-premise, when we refer to this feature in on-premise, we call it multi-region tables. When we refer to this feature in the cloud, we call it global active tables. As we mentioned before, you can access all the data locally, and you can do that irrespective of where the data was loaded. So in this example, if we had a bunch of data in Phoenix, that data is going to wind up in both Chicago and Ashburn. We already talked about the built-in conflict resolution. We talked about no need to having to make application changes to use global active tables. We talked about the synchronization. Compared to our competition, and typically when it comes to the cloud, our competition is essentially DynamoDB. So DynamoDB also has a similar feature. We are about half the cost of DynamoDB. And, Oracle provides a similar number of regions. So all of that functionality, if you're currently using DynamoDB, can be run over here on Oracle NoSQL at a much lower cost. We try to do all the replication in real time. When this is set up, you basically now get 5 nines of availability, and you really get 24/7 access of your data. You get automatic recovery after a region comes back online, and that's fairly important. So let's say that something catastrophic happens in Chicago, and all of a sudden I have more changes that happen in Phoenix, so those changes will get propagated to Ashburn. Once Chicago gets back online, right, we keep track of where Chicago was last at, and then Phoenix will get those changes that occurred there. They will get propagated over to Chicago once Chicago comes back online. And there isn't anything that the application has to do. That all happens underneath the covers. So from the user perspective, right, what you see is something fairly simple, pretty easy to use. You see a lot of simplicity. So here we have an example. On the left, we're in region 1. We have 3 different tables, of which one of those tables is what we call a global active table. And that's what this diagram is showing. So, and also, if you notice here in this diagram, right, region 1 looks different than region 2. That's perfectly okay with the Oracle NoSQL Database Cloud Service. We don't force the commonality between the different regions. So underneath the covers, what's happening is we have what we call a cloud data pipeline. So when changes happen at the sender side, we collect those changes. Those changes go into a temporary storage. Those changes are then sent across a data pipeline over to the receiver. The receiver will then pick those up. The receiver is sitting there monitoring changes. And once the receiver gets those changes, it will then apply those changes to region 2. Simultaneously, right, region 2 could be viewed as a sender. So again, we will collect those records. Those records will go to a temporary storage. Those records will get pushed over the cloud data pipeline, which we manage internally. And then the receiver now side, in which case this would be region 1. We're monitoring for changes coming from the other regions. Once we see them, once we get them, we will then apply them. So there's a lot that's happening underneath the covers, but from the point of view of the user, what you see is simplicity, because we're the ones that is managing the complexity. Just a little bit more into the details of the data pipeline. So we have the global table, we have the sender, we have a exchange zone that we have listed up here, which is what I was calling the intermediate storage. And then we have these replication transports. And this basically then shows you sort of step by step what is going on across the pipeline. So, and really what we could have on this slide is really a step zero, right? So the step zero would be a application that's coming along, doing updates to the table. Those updates could be updating an existing record. It could be an insert. Both of those types of operations would cause updates to the table. And then it will eventually, those changes will flow through this transport and get to the other side, to the other, what we call the regional table replica. And this example is just showing sort of a region 1 and a region 2. And if there was multiple regions that was connected into this table, then region 1 would have a pipeline to region 2, region 1 would have a pipeline to region 3. And so there would be sort of multiple pipelines that get set up underneath the covers. And just a little bit more on that, just to point out that all of this workflow is basically automated, and that you as the user, you don't have to worry about any of this because all of this is happening underneath the covers. So Dario showed rather quickly how to create a global active table. And in the next couple of slides, I want to break that down a little bit and do it in a little bit more bite-sized chunks. So we have this idea within the Oracle NoSQL Cloud services. We have this concept of what we call a singleton table and a global active table. And you could sort of view those as categories or classes of a table, right? So a table will either be a singleton table or a table will either be a global active table. And the process of moving it from one to another, so basically changing the table's state or changing the table's category, is you would start with a singleton table. Then what you have to do is you have to freeze the schema. Once you freeze the schema, then as Dario showed, right, then there will be this sort of add replica table button that you can hit. So when you hit the add replica table button, that will then communicate to the region that you've identified. It will then start the process of building everything on region 2. This process happens in a couple of seconds. One of the nice things with this process is if your table already has data in it, we will also move that data. And speaking about moving data, when you do this with DynamoDB, they will charge you for this initial data movement. For us, we don't charge you for that initial data movement because we recognize that more than likely customers are going to start out with data in their table, right? It'll be a small subset of customers that are basically going to create these from scratch, right? But more than likely, customers are already going to have running applications. They're already going to have data in their table. So we're not going to charge you for this initial data movement. And then once all this is all set up, then what you wind up with is active, cross-region data replication. So how do these steps look if we do it through the OCI console? And this will just be a bit of a review over what Dario showed dynamically, but I'll take a little bit more time here to describe things with a little bit more detail. So when you create a table, we have two ways to create a table, either with simple input or what we call advanced DDL. What Dario demonstrated was using the simple input, where you have a bunch of screens, you identify the table name, you identify the columns, you identify the types for each of the columns. We also have a way that, if you want to go ahead and basically write up your DDL in the SQL language, that you could then click the advanced DDL button. You could then copy and paste in your create table statement, and then you can have your table created that way. Dario talked about the provisioning. We have two kinds of provisioning. We have what we call provision capacity and on-demand capacity. The big difference between those is with provision capacity, you as the user, you decide what you want the limits of the table to be. And then the table can basically do reads and writes at those limits. Whereas with on-demand capacity, basically what will happen there is your application can basically dynamically adjust. And we, the NoSQL Database Cloud Service owners, we will adjust your read and write capacities on the fly for you dynamically. And I'm not going to go into it, but there's definitely use cases where provision makes the most sense. And there's use cases where on-demand makes the most sense. So continuing with a couple of the slides that are on the right, it shows you the create table, which is what Dario showed you. The next one down, we have a singleton table in Ashburn. And then if you notice, we have two little boxes there that we have highlighted. So we have the schema state, and we have a flag for global active table. So the schema state will be one of either mutable or frozen. And if you recall a little bit earlier, we mentioned that prior to moving to a global active table, you have to freeze the schema first. So the schema has to be frozen first. So if you try to create a global active table and your schema is not frozen, you'll get an error message. But you can also look at the schema state, because that will tell you exactly the condition of your table. So now we want to go, we say, oh, look, I don't have a global active table. That says no. We'll go over here to step 2, right? So we'll go over to the orange steps. Dario showed the add replica. Pretty basic. There'll be a drop down. You can list your particular region. The disk storage, as Dario mentioned, needs to be the same. So why does that have to be the same? Well, when you think about it, if I'm using 20 gigabytes in Ashburn and I want to go to Phoenix and I already have data in my table, then when I make a copy, I'm going to need that exact same amount of storage. So we just felt it was going to be easier to basically say, hey, the storage needs to be identical. And then if you want to tweak a little bit the reads and the writes, you can do that. So then we go ahead and then we do the add replica, which Dario demonstrated. And now we wind up with 2 tables. And then if you were to go back to the table screen, you will see that the global active flag has switched from no to yes. Since we've been talking all along, right, that we have these SDKs, it's only fair for us to show you an example using one of our programmatic interfaces. Again, the same thing here. Now, one nice thing that if you go through with the programmatic interface is we have this little option called with schema frozen. So you can create your DDL, and then you can add the with schema frozen, and then that will automatically, at table creation time, create the schema frozen. And then basically we also have a add replica request that is shown there in step 2. So this is basically going through the exact same steps that I went through on the console, but I'm now doing it through my programmatic interface. So one question that may be coming up is, why do we have this schema frozen? So let me go ahead and address that. So what happens if on region 1 I change my schema? Now I have a bunch of rows that I've added in region 2. And, you know, my plan is to change the schema in region 2, but somehow these new records got inserted into region 1 before I could get around to changing the schema in region 2. So now when these records get moved over to region 2, what happens, right? I'm going to get an error and I'm going to lose data in region 2. And what we felt from a, design point of view when we was basically putting this feature together, that loss of data was something that was pretty critical, and that was something that we made intentional design decisions from the very beginning to basically avoid. So when you really start to think about global active tables, right, you can get some very interesting combinations of things. So here we're showing you a couple of different types of global active tables where we can use them in different types of environments. We can use them in different types of manners, whether it would be a disaster recovery manner, whether it will be in a geo-distributed applications manner. There's a lot of different things that you can do with global active tables. All right, let's move over to the next, which will be sort of part 2 of the demos that Dario is doing.
So here we have an application. Okay, so that is a mobile application. As you can see here, I have a mobile application. I have a digital assistant, so it is a chatbot. And those tools are communicating with an API. And behind the scene, the API, we are storing the data in Oracle NoSQL. Okay, so for example, if you are here in US, you will go to a data center in US. If you are in Sao Paulo, you will go to a data center in Sao Paulo. If you are in Paris, you want to go to a data center near to Paris. If you are in Japan, you want to go to a data center near in Japan. Why? Because you want to reduce the latency for your application. Okay. So as you can see here, so if you want to learn more about this application, we already present this application. So you can see here the replay. If you go to events and then you go to webcast and you look for our presentations, you can see we already deployed this application step by step, okay? So here, what I want to show you, so we are saying we are boosting our application because now we want to create the same application in multiple data centers, and we will use something that we call geosteering. When we are provide, for example, an URL in the csdemo.com, he will redirect to the good data center, okay? So what I did is I deployed the same application in one region in London and the same application in Phoenix. And currently, let me see what happened, because currently I am not using global active tables in order to copy the data and have the data in all the regions in my application. So currently I have an operational database. This operational database are sending some data to streaming. Streaming is a Kafka compatible service. And then we are inserting the data. Okay, so as you can see here, we can see I have an API. I have here the description of my API, or I can see this API also in Postman. So just let me execute here. So currently I am in London. So I am executing this query. And as you can see here, I return a result. So just let me change and let me go to Phoenix. So I will execute again. And as you can see here, I have no data. Okay, so what was happened? Because I am supposed to have the same data in all regions. So multiple things could happen. So currently I am using a third solution in order to do the replication of data. But by adding multiple regions, I am adding complexity to my application. So just let me see what is happening. So for example, here, when I am retrieving the data, here I have 5 data. When I am going to Phoenix, I have only 4 data. So what could happen? So as you can see here in this region, I have mill read units and mill write units. And in this region, I have only 50. So one of the possibility is that here I am inserting a lot of data and I am not able to do the same thing in Phoenix. So I am delayed. Another possibility is here, I don't have the same time to limit. Okay, so for example, in my case, for example, I could say that here, this data was already expired, and here it is not expired, but that is not a real problem because we are talking about old data. Here we are talking about new data. But here my problem, as you can see here, is maybe a problem of capacity, or maybe I did an error. For example, here I have a table with 25 giga, and here I have only 1 giga. So as you can see here, even if I use another third-party tool, I need to manage the complexity because I need to be sure that I am reproducing everything in all the regions, okay? So now I will change a little bit my application. So of course, there is a simple solution is I can have my data and I can insert here in Phoenix. And here, for example, I am not using SQL. I am just using what we call the put API. So in fact, I am just saying, okay, I want to insert this data. I execute. And now I have the line that I am interested. And when I go to my API, I am executing and I have the same data. So our solution here now is to say, okay, instead of using a third party, what happens if we use global active tables in order to do the replication of the data directly from NoSQL tables to NoSQL tables? So what I will to do is I will come here in Phoenix and I will delete my current table. As you can see here, that is not a global active table. Here I am deleting. And here I will go to replica and I will say that I want to create a new replica. Just let me see, it is deleted. And I just will add. And here I will say, oh no, in Phoenix I have less activity, so I don't want all of these read units, replica units. And I will say, okay, I will do the same thing in Phoenix. And as Mike say, and as we already showed, we will have the same storage. If we have indexes, we will have the same indexes. We have time to live, we will have the same time. Okay. Just let me see if it is okay. Now I will go to Phoenix. We are waiting for the complete of the first data. We are ready. So if I go here and I execute again, I am supposed to have the same information because now if I query here, I have the same data here and here. Just, for example, just let me delete the data here. So I deleted all the data that I have. I will execute, and here I have no data in London and no data in Phoenix. So if you remember, I have an operational database that is sending automatically to streaming data, okay? And we are inserting this. So let me simulate this. So I will go here to, I'll go here to London. So just let me execute this. Currently, I am using a service called function. So this service is serverless. So currently I need to start this just to be sure that I have the infrastructure. Currently that is a demo, so it is not working all the time. So I just need to execute this. So just let me validate. Oh, sorry, I deleted again. It's not a problem. Okay. And now we will simulate the load. So in fact, we have multiple data. Okay, so just let me show you what I am doing. So I have multiple data. So that is a baggage data. For example, here, if I execute this, as you can see here, we have multiple data, and I will post all of this data, 20 data, okay, and I will sleep every single second, and I will send this to my streaming. So I am simulating the data that coming from the operational data. Okay. It is creating this in batch mode. Okay, so as you can see here, I have the data that are arriving to Phoenix, to London. And if I go to Phoenix, I will have exactly the same data in real time. Okay, so all the data that I have in here, I have exactly the same data. And it is not up to me to manage the complexity of putting this thing, because currently I am inserting, for example, here in London, I think, yeah, in London, and it is automatically send the data to Phoenix. If I start to insert data in Phoenix, I am able to do this. Okay, so in this way, I can be 100% sure that everything that I am doing in one region, I am doing exactly the same thing in another region. Just let me see if we have the 20 data. So we have 20 data here, and we have 20 data here. Okay, so we have exactly the same information. It is, we can say that it is between 10 milliseconds and 100 milliseconds. Okay, so let's see what we have. Of course, if we are doing this implementation on multiple data centers, sorry, I lost mouse. If we are doing this, it is because we want to avoid the latency. So just let me show you what we can expect as a latency. So I will close here. So you can go to the network. So here you can have the latency between all of the regions. For example, we can say as well. Sorry. Wow. Phoenix, and here I need to Asborn. So somewhere we will have the latency for these regions. Okay, so it is, well, I think that the best is go here. Okay, Phoenix. And so the current answer is 55 milliseconds. It is around 3 milliseconds. Okay, let me see what's happened if we pull Frankfurt and Santiago. As you can see here, it is not the same latency. Of course, that is a round trip using a ping package, okay? But if you want to have the latency in the service, we are able to show you some statistics for our service, and we are also providing what is the expected replication lag between the both states. So when you are transferring data for example, from Phoenix to London, you can expect a delay of this value. Okay, so I hope that this presentation, this demo, show you how we improve our application. Again, if you want to run the application, so there is an existing lab we can share later. If you want, you can create all the application, you can create the functions, you can create the API, you can do all the things that we did. And today we show you how easily it is to create a global active table for this application when this application is deployed in multiple regions. Okay, if you see our global demo, we are deploying in Frankfurt, we are deploying in Phoenix, we are deploying in Ashburn, we are deploying in Sao Paulo, in Tokyo, and in Dubai. Mike, I finished my demo for today.
Okay. So here, we have a link to our service page, developer page, documentation, FAQs. One of the things that we offer is a always free. It's 50 read units, 50 write units, 25 gigabytes of storage, and 3 tables. We're also offering free credits for attending this presentation. And there's also quite a bit of OCI training that is available. And, we're available to address questions. And then I'll say from Dario and I, a big thank you for everyone for attending. And then Tara, we'll pass it back over to you.
Thank you again so much, and we hope to see you at the next one.